Millions of Americans may get a rare chance to witness one of the most beautiful and elusive natural phenomena on Earth. It's a celestial ballet of light and color, an event that has captivated humanity for millennia, inspiring myths, legends, and a profound sense of wonder. For many, seeing it is a once-in-a-lifetime experience, a bucket list item that typically requires a long and expensive journey to the frigid, remote corners of the globe. But for a brief window, that journey might be as simple as stepping into your own backyard. The Northern Lights, scientifically known as the Aurora Borealis, could be visible far further south than usual, potentially reaching across multiple U.S. states this week. This extraordinary opportunity is the direct result of a powerful surge in solar activity. Our sun has unleashed a significant geomagnetic storm, a massive burst of energy and particles that is now interacting with our planet's magnetic field. This cosmic collision is what fuels the aurora, and the stronger the storm, the farther south the lights can be seen. Usually, this glowing light show is confined to the high latitudes, a shimmering crown that perpetually encircles the Arctic Circle. Residents of Alaska, northern Canada, and Scandinavia are accustomed to these displays. For the rest of us, it remains a distant spectacle, something seen only in photographs and documentaries. But right now, the rules are changing. The skies across a significant portion of the United States may light up with ethereal green, purple, and even rare red waves dancing across the night sky. Imagine looking up from your home in a state like Montana, Wisconsin, or even Pennsylvania, and seeing the heavens painted with these otherworldly colors. This isn't science fiction. It's a real possibility driven by the immense power of our star. So, what exactly is happening 93 million miles away on the sun to trigger such a spectacular event here on Earth? And more importantly, where exactly can people see it? And what do you need to know to maximize your chances of witnessing this cosmic marvel? In this video, we'll break down the science in simple terms, pinpoint the locations where this incredible event might appear, and give you practical tips on when and how to look for it. Stay with us as we guide you through everything you need to know to catch the aurora. According to forecasts, the aurora could be visible in several northern U.S. states. The best chances include Alaska, Washington, Idaho, Montana, North Dakota, South Dakota, Minnesota, Wisconsin, Michigan, Maine. These states lie closer to the auroral zone, where geomagnetic activity is strongest. If solar activity becomes stronger than predicted, the lights could even appear farther south in parts of the United States. For many Americans, this could be a once-in-a-lifetime opportunity. The spectacular phenomenon we know as the Northern Lights begins its journey nearly 93 million miles away, at the heart of our solar system, the Sun. This star is not a quiet, steady ball of fire. It's a dynamic and sometimes violent nuclear furnace. It constantly ejects a stream of energized particles, mostly electrons and protons, into space. This stream is known as the solar wind. Traveling at speeds of up to 2 million miles per hour, this solar wind journeys across the solar system. While much of it disperses into the vastness of space, a portion travels directly toward Earth. Ordinarily, our planet is well protected from this constant bombardment. We are shielded by the magnetosphere, an invisible magnetic field generated by our planet's molten iron core. This field acts like a cosmic shield, deflecting most of the solar wind around our planet. However, this shield is not impenetrable. The magnetosphere is weakest at the north and south poles. Here, the magnetic field lines dip down and connect with the Earth, creating a funnel-like effect. As the charged particles from the sun arrive, some are captured and guided along these magnetic field lines, accelerating down into our upper atmosphere over the polar regions. This is where the magic truly begins. As these high-energy particles plunge into the atmosphere, they collide with gas atoms and molecules, primarily oxygen and nitrogen. These collisions transfer energy to the atmospheric gases, exciting them into a higher energy state. But this state is unstable. To return to normal, the atoms must release that excess energy. They do so by emitting a tiny particle of light, called a photon. When billions of these collisions happen at once, The combined light creates the beautiful, dancing curtains of the aurora. The color we see depends on which gas is being hit and at what altitude. The most common color, a brilliant green, is produced by excited oxygen atoms at altitudes of about 60 to 150 miles. At higher altitudes, above 150 miles, where the atmosphere is thinner, collisions with oxygen can produce a deep, haunting red aurora. This color is often seen only during intense solar storms, appearing as a faint glow at the very top of the Maine auroral display. Nitrogen molecules also play a crucial role. When they are struck by the solar particles, they can create beautiful blue or purplish red light, often seen fringing the lower edges of the auroral curtains. Together, this celestial ballet of particles and gases paints the night sky with the breathtaking light show we call the Aurora Borealis. So, why are these spectacular displays happening now, and with such intensity? The primary reason is that our sun is becoming increasingly active. It operates on an approximately 11-year cycle, moving from a quiet period, known as solar minimum, to a turbulent peak called solar maximum. Right now, we are rapidly approaching the next solar maximum, predicted for around 2025. This heightened activity means the sun is far more likely to send energetic particles hurtling toward Earth, dramatically increasing our chances of seeing the aurora. This solar energy reaches us in two main ways. The first, which is responsible for the current event, is through a fast stream of solar wind escaping from a coronal hole. These are cooler, less dense areas in the sun's upper atmosphere, where the magnetic field opens up, allowing solar particles to stream out at incredible speeds. The second, more explosive method, is a coronal mass ejection, or CME. This is a colossal eruption of plasma and magnetic field from the sun's corona, a truly massive solar storm. When either of these phenomena, a fast solar wind stream or a CME, arrives at Earth, it collides with our planet's protective magnetic shield, the magnetosphere. This powerful interaction transfers enormous amounts of energy into our magnetic field, triggering what's known as a geomagnetic storm. During such a storm, the auroral oval, the ring of light that normally sits over the polar regions, expands dramatically. It gets pushed farther south than usual, bringing the northern lights into view for millions of people across the United States. But there's another key factor at play: the time of year. It's no coincidence that these vibrant displays are happening in March. The weeks surrounding the spring and autumn equinoxes are special for aurora activity. During these periods, the tilt of Earth's axis aligns in a way that makes our magnetic field more receptive to the sun's influence. This phenomenon, known as the Russell-McLaren effect, essentially opens a door for the solar wind, allowing for stronger geomagnetic interactions and more frequent, brilliant auroras. Because of this reliable seasonal boost, scientists and skywatchers alike often refer to this time as aurora season. Experts say the best time to see the northern lights is between 10 p.m. and 2 a.m. local time. This is when Earth's magnetic field is most aligned with incoming solar particles. To increase your chances of seeing the aurora, find a location far from city lights. Look toward the northern horizon. Choose a clear night with minimal clouds. Even if the lights appear faint to the naked eye, cameras can often capture them more clearly. Capturing the northern lights on camera has become easier than ever. Modern smartphones can photograph auroras using night mode or long exposure settings. For the best results, use a tripod to keep the camera steady. Set exposure between 5 and 15 seconds. Use a wide-angle lens. Professional photographers often shoot in RAW format to capture more color and detail in the aurora. The colors of the aurora depend on which gases are interacting with solar particles. Green auroras are produced by oxygen molecules about 100 kilometers above Earth. Red auroras appear higher in the atmosphere. Purple and blue lights come from nitrogen. The intensity of the geomagnetic storm determines how far south these colors can be seen. During powerful solar storms, auroras can travel much farther from the poles. In rare cases, northern lights have even been seen in southern parts of the United States. One of the strongest solar storms in history occurred in 1859, known as the Carrington event. During that event, auroras were visible across much of the world. Scientists continue monitoring solar activity to understand when the next major storm might occur. Solar activity follows an 11-year cycle. Right now, the sun is approaching the peak of its current cycle, which means more solar flares and geomagnetic storms. As a result, aurora sightings may become more frequent during the next few years. For skywatchers, this means more opportunities to witness the northern lights closer to home. For many Americans, the chance to see the northern lights is incredibly rare. But thanks to increased solar activity and geomagnetic storms, the skies may soon glow with waves of color. If conditions are right, people across parts of the United States could witness one of the most beautiful natural displays in the universe. So tonight, look up. You might just see the sky come alive.